Alright, now it's time for Unit 1 example project. I'm going to be using an Arduino Uno and an MPU 6050. The MPU 6050 is an I2C sensor, a position sensor with a gyro and an accelerometer on there. So I'm going to be running through the code. So here at the top I include the standard Arduino wire library, which is the library for I2C. Then I introduce some global variables for the gyro data, the accelerometer data, and the temperature, which is the things that this sensor can measure. Then it's to the setup, where I transmit little blocks of code like this. So I start off with a wire begin transmission, which addresses the chip that I want to use, because I2C can have multiple chips on one bus. It's necessary for them to have an address. So here it's just defining which chip you want to use. So that's the MPU 6050 with address 0x68 in hexadecimal. Then I want to write to register 06B, which is a sleep wake up register. So we're waking up the sensor here. So we're addressing this register and then writing zeros to it in this line of code. And then we're closing the transmission. And then the same block here, but then for a different sensor, which is configuring the accelerometer to the proper G limits that we want. So now it can display plus or minus 8 Gs in its 16-bit value. It's going to decrease the accuracy a little bit, but it's going to increase the tolerance. And here the gyro, 500 degrees per second for maximum value, the 16-bit number. And here the same block, beginning transmission to this chip, addressing the register, writing the proper bits to the register, and closing transmission. This is a little bit advanced for Unit 1. It's, the bitwise like register manipulation. That'll come in Unit 2. And here serial begin, just to open the serial bus, because we want to read those values. We want to be able to see them on our computer screen. And then in our loop, we write to the chip again, same process as before, but then we're writing to the first address of the data registers. So now we've got like basically that register selected, and then we want to read from that register and forward 14 bits, so 14 registers, because the next 14 registers of this chip are data registers, and that's what you can see here. So here in this while loop, we read all the data, and basically we're reading the data and we're storing it in a variable that we defined above. And since they're 16-bit numbers, there's like a high register and a low register. You have to bit shift the high register into the first 8 bits of the 16-bit number, and then using an OR to write the rest. And here, so accelerometer XR is 0x3B, and then here it ends with the last register. It just basically increments registers from there on. And then once we have that data in our variables, we can print them to the serial monitor, which is a fairly straightforward process.